this first lecture will be more substantive, and Elizabeth will jump in as normal to help clarify things and potentially de-geekicize things. And it focuses on what I consider essential understanding of best practices when it comes to dynamic modeling. These practices transcend the type. If you're doing quantitative dynamic modeling, meaning there's a running model, you really got to pay attention to this and put these things into practice. They have been built up over decades of sort of experience with these things. They come from many backgrounds, but if you ignore them, you're at great risk, actually, in terms of a project. So we had spoken earlier about the key need to have a model that has been trimmed and conceptually to speak to the particular purpose of that model. John Sturman talks about using the purpose of a model as a logical knife to cut away unnecessary depiction of unnecessary complexity. And as we'll see, there's some subtleties in figuring out what is and what is not needed and important. But what is absolutely essential to keep in mind from the start and on an ongoing basis is the need to have a clear purpose or small set of purposes in mind. What are you trying to get out of the model? What will be a successful modeling project? And a key part of that is thinking explicitly about those model boundaries. You may remember me mentioning this difference between endogenous things that are generated by the model that it's calculating, things that are exogenous, things that we tell to the model in a pre-specified way. They may be fixed numbers, they may be quantities that rise over time, but in some fixed pre-specified way, and things that are ignored. And when you build your model, almost everything is going to be in those latter two categories. It's going to maybe be one thing that's endogenous. And then you may work from there, but the point is that thinking explicitly about what's in this model and what's not, and thinking explicitly about what needs to be in the model for the sense of model purpose is one of those things. It's like keeping your eye on the ball in tennis, I'm told. That, even very experienced tennis players sometimes lose track of that and their game deteriorates. And they have to remember, I have to get back to this basic. And so it is here, because even the best of modelers in a fulsome moment can sometimes lose track of this at great risk. And a key realization here is adding in components does not yield greater insight. And you should be very cautious about comparing it to something like stepwise regression, where you're just planning to add things in to account for all the relevant variables or something like that.
I mean, the difference is, of course, the statistical models, it's like when in doubt, put it in. But I think here it's when in doubt, leave it out for now. That's right.
There's a principle which I cut out of these slides, but there's a principle from software engineering called the Yagni principle, Y-A-G-N-I, and it's basically you ain't going to need it. And if you're unsure, err on the side, you're not going to need it. If later your learning convinces you that yes, this is in fact an important thing to incorporate, you do a sensitivity analysis, you find that actually it proves quite important to very related assumptions, and you want it added in, that's something that could be done down the line, but don't put it in up front, thinking, well, probably this too, etc. So some key questions that came out of our discussions recently in sort of selecting both methodology and model boundary is you're going to be wanting to think about several features of the situation. Some of them have to do with the research problem you're pursuing. Some have to do with the policy environment or the state of the field of knowledge, what's known about the relevant theory. In the policy space, one thing that for me is an ongoing point of thinking is someone who does a lot of policy modeling for policy stakeholders. If I'm going to simulate interventions, what things need to be in the model to capture that intervention, the effect of that intervention? So if I want to simulate an intervention that explicitly focuses on finding people at the hubs of their social network, I need something about network structure in that model. If I'm going to have something which focuses on taking a pharmaceutical drug, I need some representation model, however stylized, for how a drug affects the person's health trajectory. If I want to focus on something which makes use of information about their past care-seeking history, I need to have in the model some accumulation of that history, some ability to accumulate that history. If it is based on geographic placement of resources, like our health region is, talking to me about, evaluating if we placed a clinic in this area of the city, I'm going to need some representation of space, of geographic context. So that's often a significant factor in my mind. At the same time, a key factor when you're contributing, whether policy or scientifically, is there a theory or a set of articulating theories at particular levels of analysis that you can tap into? Sometimes the theories are at a higher level. We have macroeconomic dynamics or what have you that may relate to supply and demand or something like that. And other times the theories are quite fine-grained. They're within an individual or having to do with interactions of individuals. And if there's a theory there that that is extant, current, competitive in terms of explanatory value, that could influence the level at which you articulate your model, because models capture theory in an operational way, in a way that allows us to say, what's the logical implication of this theory in terms of endogenous quantities, things generated by the model. Models capture these dynamic hypotheses about the world and allow us to refine them and more quickly spot mistakes in them. And if there's a guiding theory, you probably want to value that very much in your model characterization, because to have the model hold water in the literature, to have it hold water among stakeholders, to be confident about what you're doing, to make sure you're not just speculating a theory, it's absolutely a central consideration. There are times where there's a disconnection between theory on the one hand and the level at which it's articulated and the data that's available. You may only have macro data in a micro theory. And one of your interests might be, well, if we put this micro theory into place, could it lead to behavior that will be consistent with the macro data? And that might be a worthy thing to look at, but you want to make sure that micro depiction of behavior is not totally speculative and uncertain, because you could posit this, you could posit that. It might be a useful thing for theory building, but you'd like to have some sort of understanding about where to begin in that space of theory. If, by contrast, the data is available at an individual level and the theory is at a level of the macro behavior of the system, you've got a real challenge, because you've got some understanding about empirically about what's going on there, but without at a lower level, but without a theory to kind of make sense of it. You've got at least some work cut out to you in sort of theory building at that level. And it may be that you then engage in a certain amount of grounded theorizing based on the data.
Although something to keep in mind is that it's often easier to predict more aggregated outcomes than micro ones. Like if you were really testing the fidelity of your model, you wouldn't necessarily want to say, do I produce the same patterns at the city level as I see there? So a bad theory can give you in some ways misleading predictions at the aggregate level, but if you disaggregate, you might discover that you're not doing as well as you hoped.
Okay, so some features of the research problem. Certainly if there's pronounced impact, not just of heterogeneity as sort of as observational heterogeneity, but heterogeneity that there's some theory to suggest that it's important or some reason to believe that's important. You see big disparities between the characteristics of individuals behaviorally. And that may be demographic, it may be contextual, people at certain locations in the city or certain locations in a certain region or in a network have certain characteristics. You've got to be wondering, okay, is heterogeneity critical for understanding this process? Is it critical for describing it in a plausible way, for capturing the outcomes of interest? Sometimes we're very interested for obvious reasons. This is something that troubles me actually sometimes about aggregate models. When you use aggregate models that aren't stratified, they don't sort of layer the model by different subpieces of the population that then interact at certain places in the model. But if it's purely homogeneous, one has to be careful because transfer effects won't be captured in that model. Effects which benefit one group at the expense of another.
Aggregate models basically means at the level of the population.
Yeah.
Sort of like
Yeah. So if it's not make a distinction, say between a low SES and high SES individuals, and you're examining policy impact, there's an implicit value assumption there that transfer effects are not as important as overall outcome. That the overall gain, an overall gain that's positive, it doesn't really matter whether the burden's on the low SES population and the gains are on the high SES or vice versa. And that troubles me from an ethical perspective, and it's one of the reasons that if I use aggregate models, system dynamics models at an aggregate, and I'm doing policy analysis, they are typically stratified models where I'll capture men and women, or I'll capture different SES levels or what have you within them. Vulnerable groups within them. So just bear in mind that heterogeneity is an important motivator for sometimes in terms of explaining the process in a plausible way. It's an important motivator for capturing disparities, et cetera, that may be of central interest to a stakeholder. And it may be of great interest for assessing the acceptability of certain intervention outcomes, for example, or assessing the gain from certain intervention outcomes. You also want to, we do modeling in human theater. And system dynamics emphasizes that particularly, but I think there's a growing appreciation across the modeling spectrum that if we want to build useful models that get used, we need to be thinking about people's reaction to them, who's going to use them. We have to make sure there's capacity to do that, but buy-in and a sense of ownership, etc. And stakeholders often react quite strongly to model boundary issues. And you have to be cautious because there's education that has to be done about, look, we need to do is one step at a time. We have to start simple. We'll get somewhere. And we can't put everything in because that will take a long time to give you anything. We have to start one step at a time. There's some education there, but certain stakeholders you'll find gravitate towards certain representations. Worked with a demographer at one time, and for her, actually dealing with an aggregate model was very comfortable. She was used to dealing with aggregate quantities as a demographer. In other cases, I work with clinicians, and their world centers around individual patient flows, etc. And sometimes they find stocks and flows a little bit too abstract for their comfort level. It requires them to push out of their comfort zone. But if you show them a model which depicts individuals, then the excitement really comes out. Yes, Elizabeth.
Before we jump into more details of best practices, I want to make kind of a meta, or these kinds of building a model of best practices, I want to make a meta comment about the material that was discovered, because we've been presenting it in the context of making you better modelers. But it's also giving you principles along which you can evaluate grant proposals, or you can evaluate journal articles. So think about these things as being things to ask yourself when you're evaluating the work of others as well.
Yes, it's a very good point. I will tell you that, and it troubled me as a computer scientist early on, that visualizations of models for stakeholders, they make a really, really big difference. And one, you can see I'm not into user interfaces that much, I guess, switching there. But no, visualizations are really useful. And they're useful not only for building confidence among stakeholders, actually they're really useful for spotting issues with your model, for spotting weird patterns that aren't plausible, or for spotting very interesting dynamics that you want to investigate. Visualizations are not eye candy. They're not merely fluff that is used to kind of have people look at it. So I actually spend a lot of time with modeling with visualizations to try to make best use of the model.
When you say visualizations, are you talking about just simply like running some analyses on different subsets of the population, or are you talking like more causal diagrams?
So systematic analyses on different subsets of the population falls into the next slide, and we'll talk about things with that, and particularly sensitivity analysis and so on. But what I'm talking about is graphical depiction of what's going on in the model using anything from classic analytic outputs, things like plots over time, histograms, scatter plots, box plots, population pyramids, that sort of thing, all the way to the sort of depictions you saw with the agent-based modeling, where you have individuals circulating in a network depicted with the network structure depicted, or you see geographic space. And I will tell you that geography and GIS type data, I have never seen something more invigorating to a group than GIS depictions. I remember particularly one. I won't mention the institution of interest, but I had one. So I run these series of boot camps, typically several times a year, internationally on modeling, and many of them focus on agent-based and hybrid modeling. And there was one group. It's the only boot camp I've had that's been a bit combative. Basically, it was a group of really hardcore health economists who were very, very, I have a background in cost effectiveness analysis, so I'm perfectly comfortable in that space, but they were very, 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 very sort of skeptical of wanting to adopt another tool, and they also really, if I was going to present to them, they wanted to see the things in the model that were specific to cost effectiveness. So, cost effectiveness plane and doing analysis across multiple realizations with the same parameter sets, etc. And I did that for them live, because that's how I do these things. And they seemed okay, happy. But the thing that totally exploded the room with enthusiasm was these sort of fairly staid health economists was when I showed them a GIS visualization. They started to giggle and get into it and put supermarkets down or what have you and play with it, and it just brought out this levity and sort of enthusiasm from them. And what I will say is GIS data, geographical data, policymakers, policy analysts, people from all sorts of backgrounds can relate to it. And often they don't fully understand what you're trying to do with the model sometimes until you show them a visualization, and a geographic visualization is about as good as they get in terms of bringing this out. I don't know why. Experts in human-computer interaction or psychology might have an idea, but maybe it's because you show them a picture of their city and they can relate to that, and they say, oh, I know what that is, and oh, there's an agent there at the corner of that street, okay, I know what it is. And you wouldn't think it should matter that much, but it does, because they're people too, and sometimes it's a bit abstract until you show something very concrete. That's been my experience across a lot of modeling projects. if you want to help people understand what modeling is, you show them something very specific. Okay, let's talk about best practices though, because time is a-ticking, and we're eager to get on to learn from your presentations. When I say we, you can include yourself in that, if, or not, as you feel comfortable. Okay, in terms of best practices beyond this. This is something, again, we've repeated many times. Modeling projects always start simple. And even if you think you're going to a rich policy model down the road, develop incrementally. Add one thing at a time. When I say one thing at a time, we're talking about adding in a chunk of work that adds like a feature to it. It may be a couple things, and you create a new version of the model. And that version is something that remains unmodified, except for any sort of error correction. And then if you're going to add something in, you create a new version. And you save away those versions because you may want to go back and reproduce something you saw earlier. And if you no longer have that version of it, it's a hard thing to do. How did I get that? It's the worst feeling if you get a paper review back and it's like, oh, they just want to see this additional analysis. I could do that. And then you wonder, what version of the model was that?
I would also create a text document where you have like model 0.1. What was in it?
And that's
model,
that's this record of experiments,
like
but also
what? It's like the equivalent of a log file.
Exactly.
Yep.
There was somebody, I feel like this week talking about there's some kind of software that where you can save it.
Oh yeah. This is our life as software engineers. Git. Git. G-I-T. Yeah. Go get it.
That's a free.
It's a free. Yeah. It's most certainly free. It comes out of the open source community, and in my boot camps, I actually talk about this more. It's called version control, and there's a long history of version control. There's RCS and SCCS, et cetera, and this is sort of the latest one. It's a very good system. It allows teams to develop with it. It saves away successive versions. It allows you to see the difference between your current version and any previous version. It allows you to put comments for intentions. So this new version of the model, what's different about it? Like, what was it designed to do, or why did you create it? What did you add? That's all par for the course for how we build software. And it does allow for going back as far as you want and finding a previous version, and you could compare, and in principle you could have both versions and kind of run the model and see the difference, et cetera. But you want to do that not just for the models, save away the models. You want to have a good log of the experiments you do with the model in the sense of analyzing the model, particularly there's a certain amount of exploratory work you may do, but generally speaking, if you're going to do analyses that are carefully considered, you want to have a record of why you did it, the model version that it was run with, the parameter values or the assumptions that you used for that particular scenario, potentially a random number seed and any results. So we have a system for any logic which was designed to automatically record this, except for intention, which you have to tell to it. But basically it actually saves away all the information. It takes a screenshot of the results of the model. And so you can think of it as a lab notebook for modeling. A lab notebook that allows you to have a record of your interaction with the model. And this is really useful because sometimes you're not sure, where did this weird behavior I've just noticed, particularly take a note of, where did that first come in? Did I see that and just not make note of it, earlier? And by going back, you can go see early results. It also gives you a clear record when you did that paper submission, what were the assumptions that went into it? Not only the model version, but the assumptions about this. Basically, folks, this is about reproducibility.
So
It's a basic issue of scientific research.
and that logo also has something under tools where you can tell in that logo to run multiple runs of a model and very systematically parameter settings, and it saves all of the results in an Excel spreadsheet. So that's another way of automating certain model runs. It's very convenient.
Right.
Is that, the behavioral space in that logo, is that often used for sensitivity analysis?
It can be used for sensitivity analysis, but you can also use it if you're exploring, say, the implications of two different decision rules. So it can be used for substantive analysis as well.
Yeah. And this, the same basic feature in any logic, with sort of, it's called a parameter variation experiment there, but you can use it to turn on and off parts of the model if you want to.
What's nice is that it gives you output where it saves what the parameter values were and what the results were.
Yeah, that's nice. So when you're developing incrementally, not only are you going to be careful to save away each version, this version, when you do a logically sort of related chunk of work, not only are you going to document that, have a model version for it, etc., but what you want to do is you want to take those versions and compare them with previous versions. I'm going to cover this more in the next slide, but there's a process called docking whereby you'll compare the results of the newest one with the previous one, and you'll learn from that. You'll spot errors more quickly, and even more importantly, you'll develop understanding about where certain behaviors come from. These versions you can also show frequently to stakeholders for feedback and for knowledge elicitation. I said earlier in this lecture, but in separate lectures too, that stakeholders often have tacit knowledge that doesn't come out until you show them something. And you can show them these versions of the model and get feedback from them about its realism, about their thinking about it, can help them learn from it, and potentially about change prioritization, as we'll see. Key thing that we make use of extensively in our work is a set of practices from software engineering that are industry best practices that have to do with what's called, in software and development, it's called pair programming. Here it will be called pair modeling, and it's a great thing. The idea is you have two people working on a model simultaneously, and it could be a very senior person or a junior person, or it could be people of comparable levels of background. Either way, both sides will learn, and they'll spot issues with the model that wouldn't have been spotted earlier. You might think naively it's very wasteful. You have two people spending their time in this instead of one. Couldn't they instead be doing different things? Actually, it pays off in terms of productivity, because people think more clearly when they have someone else to bounce ideas off of, and it cuts off iteration to fix an issue that would have been spotted with another pair of eyes. It cuts off misunderstandings, and it also communicates to the other person. So now you have two people who completely understand what's in that model. Another technique that we use a great deal, Kurt's participated in quite a few of them, are what are called formal model inspections. And again, this is a best practice that's been shown to be incredibly effective in the software industry. And here what we basically do is we have a formal process for taking a model, sharing it with people ahead of time, having a meeting where people have defined roles, present the model, and people bring critiques from having looked at it earlier. The critiques may be about model scoping, it may be about sort of the formulation of the model, how we are capturing some of the concepts. It may be about model implementation. People bring concerns there, they discuss it. This is something that has been shown to be incredibly effective at catching problems. It's actually much more effective than software testing, and it's much more efficient than software testing in terms of human time per defect found. But not only that, it spreads knowledge around, because everyone who participates in it now knows something about that model. And often it spreads best practices around. What are good ways to capture things? Very, very effective. It can be done remotely. There are systems to perform it with people who are not physically present. And we like to do these for our models, particularly at certain key points in their development, like when we think they've reached a certain stage or what have you. Another technique is performing simple tests. It's a good practice with your model to run it with parameters where you think you know what the result should be. Maybe because it's particularly trivial. We only have one person in the population. Or maybe it's because certain effects are left out. We turn off networks, so nobody's connected with anyone, for example. Or you run it with sort of extremely high values, hazard rate of a certain behavioral occurrence happening. You turn off a flow in a system dynamics model. You turn off the initial value of, you make the initial value of a stock 0. You run it with a small population. And you use that to sort of test your understanding of what's going on. Often you can spot issues with it. Sometimes you can spot new points of learning. We'll often take the model, in system dynamics, there's a particular emphasis on what's called extreme value testing, where you basically take the model and you use it with very extreme values of parameters, so 0 or very high values, and you use that to sort of make sure that it behaves in ways that are appropriate and sensible for that. Okay, so we do testing. Yeah.
Yeah, I just want to interject. So with ABM, I was not sensitized to the value of doing this until I had a big bug in a very complicated program. And part of the problem is you may have so many pieces of the model, something's going wrong, and you don't know what it is. So one of those sort of the key phrases is unit tests. Are these things where you isolate a piece of the model and you know what the outcome is supposed to be? Like at the end of this, the agent moved from X to Y. You turn off all of the stochasticity. You're basically zeroing in on a particular step where you know what the outcome is supposed to be. And then you make sure after you run the model that it's exactly where you think it is. And one thing to think about when you're building the model before it kind of gets out of hand, and if you're writing grants, you could include this process as part of your model building because it will add time to the development stage, is to identify like what are key functionalities of this model and can I isolate them to systematically test them one by one before the model becomes a final product and it's hard to swap these errors.
And there's some implications. This class does not touch on implementation of models, of sort of how we cast it into code, how we cast it into a runnable form. We talk some about design, but not so much about implementation. But there's some extremely important principles to make that happen. And once again, it's an industry best practice in software. Give you a sense that system I talked about yesterday, that smartphone-based system, when it was still in our lab, it had something like 900 tests associated with it. That every time we made a significant change to it, we'd run these 900 tests. And it would test all sorts of different subpieces of the system, many of them very isolated, and then do some coupled testing and so on to spot did something go wrong. And with models, at the least you want to do this in a manual way. You want to sort of try running it with different assumptions in a frequent basis just to make sure something hasn't gone awry. The earlier you can spot a problem, the better, because the longer it's been since it came into the model, the more things that have changed since then, and so the more things you have to wade through to find it. If you can be doing tests fairly frequently, there's only a few things which changed since last time. And so there's only a few places the problem could be, if you notice it, if it didn't occur there earlier. If you do discover errors in implementation or oversights in your thinking about how the model captures things, try to use them to improve how you build models. You should be asking yourself, not in a self-flagellation sort of way, but in a way, how can I do this even better? What allowed this to creep in the first place? Was there some element of understanding that I need to brush up on or learn from? Do I need to consult with an experienced modeler? And how did it go unnoticed for so long? If it came in a while ago, what was it about how I'm doing things that allowed it to creep through the system? And this is what we do again in software. We have this continuous improvement where we try to we fix an issue, but we try to say, okay, what led to this issue? What led to the vulnerability to it? What led it to be undiscovered for a while? If you have a model which has coding in it, system dynamics models are actually quite good in terms of not having individual pieces that are really puzzling. But if you're dealing with a model, I don't care if it's a NetLogo or AnyLogic or Repast, where there's code, where there's programming code, that you're not going to be able to show to a stakeholder. You want to be especially sure you have a high-level specification for that model. Chances are you'll use it for a paper anyway. So you might as well create a high-level description of what is this doing? What is it accomplishing? Putting aside for the moment how. That code does something. It accomplishes something. Using these inputs, it outputs things like this, or it makes some appropriate change. And you should have a high-level specification of that that's different than the code. Code is not something which is acceptable as documentation in this context.
So one thing that people use for ABM is called UML, Unified Mapping Language. We talked about it yesterday for yours. And there's pictorial representations of what the agent's properties and actions are, and also pictorial representations of what a step of the model would look like.
Right.
And that can be one way of providing a higher level documentation that's not just
And I cut that out of this presentation, but you'll find other presentations where I show it because we use UML over on the software side. If you saw those state charts in AnyLogic, the sort of flow charts, some of the ideas with the parameters there and so on, those are UML diagrams, those state charts, for example, and they're very helpful for communication.
And when you're writing grants, don't forget to add time for documentation because it's very time consuming.
Yeah.
And if you don't cover that time, it's kind of you're in hell. Like so, for lack of a better way of putting it. So make sure you account for the time needed to document and clean up your program so that when you store them and need to access them at a later date, you won't.
Yeah, and I'll just make a point here because this is one of the bugaboos over in software, that when you're maintaining a higher level specification, be sure to keep it current. Be sure that it doesn't just become an outdated depiction, because then it'll be actively misleading. It won't be telling you what's in the model, it'll be telling you what was in the model a year ago or something like that. So you want to make sure there's that commitment and there's that time to keep that updated. If other people are working to contribute to the model, probably not as likely for your models. Integrate with them frequently and in very small steps. That too is the best practice. And something we didn't talk about in this, but you can find dozens of lectures of me talking about it online, is sensitivity analysis. Sensitivity analysis is a process by which we systematically and rigorously examine how model outputs, and sometimes higher level constructs than that, I'll talk about that in a moment, vary as you change assumptions about the model. And often those assumptions are parameter values. They're the number that we put in for, the likelihood that a peer educator, when they speak to someone who's not practicing this health behavior, will convince them to practice it. Some quantitative assumption, maybe it's the population size or something. In other cases, we will vary something like whether a certain element of the model, a certain element of the depiction of the natural history of the disease, for example, is turned on or off. So we'll actually disable and enable portions of the model to examine the results of the output. That's called structural sensitivity analysis in the SD world. Yeah.
One thing. Did you want to ask a question?
No, finish the sensitivity analysis. My question goes back to model documentation.
Okay, good. So sensitivity analysis is obviously important for understanding how your model results will change under different parameter specifications, but something that even very famous modelers do, which is kind of horrifying mistake that you should try never to make, is to mix up sensitivity analysis with model fit. Just because your model is robust across parameter specifications tells you nothing about how it fits in capturing a real world process. So don't present a sensitivity analysis as, oh, it was robust, so I'm comfortable, I'm not worried about how well this maps onto real world processes. And when you're reading grants and articles as a reviewer, it's very, I think one of the things that our OBSs, our community around best practices talked about a lot is like, these things really need to be separated because people will put in a sensitivity analysis as a way of assessing model fit and then walk away saying, oh, it's robust, no worries. And that's not the same thing as comparing your model output in a rigorous way to real world data.
Yeah. Sensitivity analyses are very easy to undertake in most modeling packages, as noted. Automated. And they are often very insightful also for model scoping in this incremental development process because
you might want to say what model scoping is.
Yeah, choosing the boundary of the model. What we talk about, the scope of the model as being sort of the set of factors that are captured within the model, particularly this distinction between endogenous things generated by the model, things the model tells us, and exogenous things that are pre-specified to the model. Those are things we tell the model, and ignored things. And when we're thinking about the degree to which things should be endogenous or exogenous or ignored, one of the best ways to inform that is to perform a sensitivity analysis where we will do vary something related to that, or ideally a very simple representation. If it's very sensitive to it, it may well be worth making into a more detailed representation, or a more, let's put it this way, a more considered representation, more articulated representation, because it's very sensitive to the assumptions about that. On the other hand, there's a lot of cases, and this is a feature of nonlinearity, ladies and gentlemen, where we have a big uncertainty about something, but it actually doesn't change the output much for any of the realistic range of use of the model. So you may, have an uncertainty by a factor of 3 about the value of this parameter based on, a meta-analysis that was performed, or based on estimates from the literature, based on expert judgment that you get access to, but it turns out to be very insensitive to it. By contrast, there may be other parameters to which it's very sensitive. And sensitivity analysis, performing it at the least by hand, using value 10% above its current value, 10% below, and seeing the difference, or better yet, systematically running it sweeping across a number of different values. They're sometimes called parameter sweeps, that sort of approach, is a really good thing to do. And let me mention one thing. It's very hard to get a modeling paper published if you've never done sensitivity analysis. Or let's put it, if you haven't documented that you have done sensitivity analysis and showed findings from that sensitivity analysis, or put in comments. That's an area where people view the absence of sensitive analysis as indicating that you're not serious about investigating the behavior of your model. And there is, and I'll be with you in just a sec, Brenda, there is a frequent beginner tendency to create a model with certain parameters, run it, say it looks plausible, and then try to share it as a finding. And that is a sign of great naivete.
Yeah, but and then we should move on, so I really don't. But it is a current problem in this field, that people focus only on the sensitivity analysis and don't rigorously try to compare their model parameters and output in a way that assesses model fit with actual data.
Yeah, and once again,
most studies stop at sensitivity analysis, and that's considered, you've done due diligence, and it really isn't enough for a model where you're trying to explain real world processes.
Yeah. If you haven't compared to assess the face validity and shown that the model has some plausible sort of relationship to real world data, it's quite different. It's very different from sensitivity analysis. A model could be Yeah, completely
And we don't
unrelated
have,
to the
we
world.
don't have a methodology in system science for how to do that. That's well established in the literature. But for example, atmospheric scientists, people who predict climate change, those are simulation models. And there's a well-developed methodology in that field for like, gosh, I probably want to know if my climate change model fits the data in some meaningful way, right? So those methods are out there, they're just not really integrated into the public health literature.
And if people were interested, depending on the type of model, ABM is quite different from SD. Within the SD community, there's quite a lot of discussion, actually quite a large literature on model elements of model validation or falsification, and certainly separately on calibration. Within ABM, we use very different methods with the stochastics and so on, and non-parametric statistical tests are part of our routine toolbox, but there's a set of others too, because it's not always point matching. You're not always trying to match time series data over time on a point-by-point basis at all. And it lends itself to a whole course or a whole series of lectures just on model, building confidence that a model actually corresponds to something meaningful in the world.
Are there readings you can recommend on that?
Yes, I have some readings. Yeah.
So, two questions. So
Yeah.
I wonder if this is a function of the fact that like the public health literature is particularly new.
Yeah.
Like ABMs are particularly new because in terms of the I've like looked at the supplementary files like with model documentation for a lot of the ABM papers, and it can range from just reporting the probability models that were used to fit different pieces of the model to like stuff I can't understand. And so so my question is like if there's a good standard for what should be included in model documentation.
There's actually is it Volcker and Grimm?
Yeah.
There's
ODD plus protocol.
There is a set of papers
Yeah.
on one set of standards. Personally, I don't love them. I don't think that they're well accepted in the community, but they are out there, and it's important for you to know about them. So maybe we can like post a reading about that. But this is an area where one thing to think about as you move ahead with your projects is that you all came here with substantive questions, but each project has the opportunity to iterate a little on improving the methodology, and it increases your edge in getting grants and getting your paper published. And so these types of things are things that really need better development, and so they can be areas where you can also make a contribution.
Yeah. I'll just say I'm more positively inclined towards ODD plus. The original ODD had some issues. ODD plus stands for Overview, Design, and Details, and you'll find videos of me talking about it going back 5 or 6 years online as part of kind of the modeling process. I'm more positively inclined. We have contributed models that are systematically described. At the least, it forces you to think systematically through what goes in your documentation. And basically, there's an overview, there's a design level characterization model, and then a detailed level characterization. And the plus version, versioning was very important for it. It added some refinements to it. And Volcker Grimm, Grimm, at Cal State Pomona, I think, together with Steve Railsbeck. They contributed, and it's described in a book called Individual-Based and Agent-Based Modeling. There's a book contribution. Volcker Grimm is a prominent agent-based modeler in the ecological modeling area, who's published much on philosophy of modeling, particularly what he calls pattern-oriented modeling, including the pages of Science.
Okay, that's
Yeah.
super helpful. And then my second question
Yeah.
is, we talked a lot about how the modeling process is iterative, and like your models themselves can be iterative. And
Yep.
so like when you're thinking about publishing, at what point do you decide this is enough to like stop and publish, and like what aspects of your model would constitute paper? So for example, in mine, like I'm thinking about a model of Mary's progression, and that alone is probably
terms of the substance of the model, like what the model delivers in terms of insight and knowledge, I think enough is really when you feel like the model has given you a publishable result. I mean, a result that contributes to the literature of whatever magnitude is acceptable in your field. Now, that doesn't mean, I think part of what you're getting at is there's always more you could do and more you could add on, and I think it's no different from statistical analysis in that sense. That you have asked when this is part of why it's so important to pose the question up front, because there can be kind of mission creep as you go along. And I think the thing to ask yourself is, you pose a research question that you know is not accounted for in the literature.
Yeah.
If the model gives you insight on that, that is what you are ready to publish on. Now, in terms of is it enough, like how much sensitivity analysis do I need to do? I think that's a subtle question, and it's often why it's better to have a modeling team when you have someone who is a designated modeler on your team who can use their judgment about that. I mean, obviously, you want to feel like you have interrogated the focal parameters of your model, but what that means in practice is going to vary from project to project.
Yeah.
I think in terms of, do I need to now make sure that what my model is doing maps onto the quote-unquote real world? That is a really hard question, and a lot of it depends on what the goals of the model are.
Yeah, and maybe I'll just make a statement here. So I agree with Elizabeth that the minimal publishable unit, the MPU problem, is a familiar one to academics, and I often slice the salami too thick, the veggie salami. But the point is that it depends a lot of where the learning is. What's a perceived contribution? Let's be very clear. From a given line of model development, there can be many papers, but each is going to have over time a different focus and different contribution, and different insights that it is contributing to the literature. I just last week I published. I delivered a paper on which Kurt was involved, which was an extension of a model Kurt did earlier to explore some dynamics associated with trust, and it added in an additional thing. And it goes without saying, you need a hook, that's quite unique to this paper that distinguishes it, some particular thing that you focus on for the paper. You're not going to get a paper out typically, with some exceptions, you're not going to get a paper out that says, this is the model, it looks plausible. There's not, in my experience in the health field, there's not too many papers like that, although they do exist. What generally you want is a paper that has a description of the model, and it uses it to find something substantive about in the health sphere, which is a novel finding, and that's easier to get published. There's more journals that will often welcome that. A description of the model by itself can be done, and in today's broadened landscape with open access publishing and so on, with longer papers allowed, that's maybe plausible. One thing I will say is we've gained a lot by having model lines of development where later ones can refer to the earlier ones for more details about the model. And so we don't have to every time re-describe the model from scratch. We can refer to earlier ones. I will also say, as a computer scientist, because if I don't say it now, I don't know when it will be said. So let me just say it. I want to clear up something, because from a distance, I have to say many computer scientists kind of probably look kind of similar, and perhaps not always in ways that you consider flattering. But you have to understand, we computer scientists are a very diverse group of people. And when you're thinking about a member of your modeling team who has hands-on the model, is sort of doing the heavy lifting, adding to the model, it's easy for people from health scientists to get caught up in the idea that the primary thing that person is bringing is capturing things in code and therefore they look for a computer scientist because they think we're all about code. First of all, most computer scientists are not trained as software developers explicitly, okay? And so there's lots of computer scientists who know very little about building a good system, implementing a system that's robust, easily evolvable, and so on. So if you pick a random computer scientist off the street, you may get a database administrator who's not going to be very helpful for even implementing model. But more to the point, the biggest point of the place where most things can go wrong and where you really need the greatest expertise and virtuosity from someone doing heavy lifting with a model is often not in the implementation phase. It's actually the implementation of it, the casting of the design into code. It's asking what's in the design. And practices like sensitivity analysis, if you pick a random computer scientist off the street and you ask them to implement a model from you, you're asking for a world of hurt because they're not trained in characterizing real-world systems. And unless you give them a very, very prescriptive sense of the design, I want you to do exactly this, they may go off and do a weird set of things, which is not very helpful.
Just to put this in context, one of the things that's happening now in the field as it's sort of exploding is that we're seeing a lot of proposals where people are like, here's a really cool problem. Don't worry about the model. I've added a computer scientist to my team. You know, and reviewers are like, what? You know, that's not. You want someone who has experience developing these types of models. It's not just enough to have someone who knows how to write C++.
Yeah.
That's where this is coming from.
And
it's like a big problem right now.
It will go down a dead end street, and you'll pay them a lot of money, and it will not be very productive. And it'll be horrible. It'll be horrible. Okay, most of the time. And what you really would like is someone who knows a lot about modeling and about the needs with modeling, the needs to keep it simple and what's likely to change and what's likely not. They can span this world between implementation of a design and sort of what needs to go into the design. And they can give you feedback on, gosh, if we incorporate a design like that, there's going to be these issues conceptually with pursuing the project or potentially these big issues with implementation. So they need to be a very special type of computer scientist, a type like yonder gentleman.
I feel like at the end I should give a bow or something.
Yeah.
I'll be here all week.
No, so honestly, you do just don't. We're not all in the same boat, and you want to consult with people who know the computer scientist world and at least pass resumes in front of them. Like, is this person look like a potential fit? So I cannot tell you how much angst it was to see a very promising modeling project go totally off the rails at one point. One that had access to a tremendous amount of knowledge, superior sort of sets of expert background in which to tap. But they had basically a series of programmers they didn't know what the programmers were doing, and the programmers didn't really understand what the expert stakeholders wanted, and it just led. It was just, and the programmers they weren't software developers. They were just computer scientists or people who picked up programming on the side of their desk, and it was a complete disaster, and it burnt years, and it cut short enormous opportunities, and it was with great angst that I looked at the situation, and you don't want to get in that standpoint. Okay, moving on. I've talked enough about incremental model development. I'm not going to go into this further, but this is absolutely essential. And you put yourself at great risk if you are just trying for the big, great model up front. Your stakeholders are going to be waiting far longer than you think, and if it runs, you won't know where the dynamics are coming from. you won't know if a certain interesting phenomena is a interesting emergent pattern or a bug, and you're gonna end up trying to rediscover learning. It would have been much easier to get when doing it one step at a time. You add something, you see something weird, you investigate. Oh, is this an emergent property, some unexpected, a surprise thing coming from the model, or is it a bug? You've only changed one or two things. You can zero in on it quickly. You can resolve it, and you can show it to stakeholders along the way. And you can estimate how long it will be for the next one. It's once again a best practice from industry. Okay, those are, and very critically, by doing so, you learn from the model. You may end up with a model with the features needed to address that policy landscape you're interested in, but it'd be a vastly more savvy model because you've learned each step of the way from the modeling, and what you end up having in the model might be quite different from what you would have thought up front. Because you've actually learned from sensitivity analysis, you've learned from seeing where emergent patterns came out. You learned something you didn't know earlier. Okay, I think I'll stop there. Do we want to take a break now, or should we jump into the wrap up?
Why don't we push through the content and then take a break before we start the presentation?
Great. Okay, I will put this on the website. I am behind in that. So we will now go to the issue of model wrap up here, and course wrap up. Yes.
Should we be sending out the link for the Google Doc?
For this Google Doc?
Yeah.
Sure. Do you have a Google account?
Yes.
Okay.
Oh no, don't say no.
Oh,
Did you
okay.
break? Sorry.
Okay.
Just
Okay. Happy to do it. Great. I shared it with you a Google Doc, right?
Yeah.
The wrap up.
Wrap up in Google Docs.
Yeah. So no, this wasn't it. Okay. Give me just a sec. I'll just go to it. I don't know. Nope, it's not in that one. Okay, let me just get down to where the boot camp stuff is. Here we go. There we go. Okay, there the boot camps. Come on. Okay. Oh, come on. There we go. Okay, boot camps team development folder. Okay, I teach a lot of boot camps. There we go, and here we go, notes and wrap up. Okay, we can stop this.